Hello again, this is Mark Summers from Summers Technical Services. We're going to follow up with our video earlier about the sheet metal flat pattern calculations. And so now that you have those values, we're going to build a model in Solidworks and check to verify that our hand calculations match the real values in the model. So let's get started. So the drawing you've got will tell us the dimensions here. So I'm just going to start a new part model, File New, start a new inch part like I always do, and we're going to orient this part such that it sits like it does on the drawing. So this is going to be the front plane where the ordinate dimensions start. This is going to be the right plane, and this is our top plane. And so this first sketch, we're going to build this feature, this face here first. We're going to call that the base tab, or base flange. So we're going to build our first sketch here, just like we normally do. So I want to go Sketch, pre-select the front plane, and now I'm able to start making my sketch. So I want to draw something like this, and be a little bit careful that I draw it reasonably accurate, but not get too worried. And it looks like I didn't close it out, so I want to make sure those are closed. Now I know I have a closed loop, which we always want. Alright, well, it looks like I was able to get this line coincident with the origin. That line's coincident with the origin, so that's correct. That's 0. And then maybe I know this part's symmetric, so maybe I'll grab these 2 points and add a geometric constraint for those, and also make these geometrically constrained because I know those are going to be the same location because the part's symmetric left to right. And the rest of them maybe I'll locate with dimensions. Okay, so we're doing something a little bit different on this one. This has a whole lot of features and a whole lot of dimensions to control those features, and we want to not use regular linear dimensions. We want to use ordinate dimensions and make the drawing less cluttered. And so to do that, instead of going smart dimension, we'll use the pull down and do ordinate dimensions. And I haven't put the holes in, I haven't put the pockets in. I'll let you do that later in a different sketch, but you'll do it the same kind of way with ordinate dimensions. And this way this first sketch will be pretty clean. So I'll go ordinate dimension, and I'll start doing the horizontal dimensions first. This is where I'm going to start, because that's where the drawing told us to start. So I'm going to click that edge and then place an ordinate, place the 0. And then I'm going to maybe grab these edges here, and here, and over here. And so those are my first group of ordinate dimensions, and they move together. And this is going to be nice when I do my drawing. I'll be able to move those together. Now I'll go do another group of ordinate dimensions, and maybe I'll put these on the top so I don't get too cluttered at the bottom. So I want to make another 0 dimension here, or an ordinate starting point, and then I want to do this edge, or that corner, and do all these corners here. And I don't want to do this one because I've already got it down here, so maybe that's all of those. And again, these move as a group, and if you miss one, say I forgot to put that one on there, whoops, say I forgot to put that one on there, well, to add that one in that I missed, you just right click on the ordinate and say add to ordinate, and then click the one you missed, and then now you don't have to delete the whole group and start over, and now they're all grouped together that way. Alright, let's do the other direction. So I'll do ordinate dimension, start at this 0, and maybe define this point, or place the ordinate first, and then define that edge, and maybe say okay, that's good for that. So there's another group. And now I want to put these other corners, maybe I'll group them over here. So I'll do one more group, ordinate dimension, right here, place the 0. Whoops, what happened? Ordinate dimension, place the 0. Here we go. And then go boom, boom, boom. And why don't I need that one? I'm not sure. Look at this, I got a mistake here. When I was sketching, I didn't pay too close attention. It thinks that line needs to be perpendicular to that other line, which is obviously not what I want. So I'm going to delete that. And now that's why this one, it didn't think it needed it. It thought that was going to be a driven dimension. So I need to right click on this guy and again add it to ordinate so I can add that one additional one. And there's the ordinate, and there's the edge I want right there. Alright, now I think I've got them all on there. Are these still grouped together? Yep. Alright, so now I need to just quickly change these values. So I think this is 8. This is, I don't know what this is, 5.75. 2.25. This should all be symmetric. This is 0.6875. These are all rounded on the drawing, but they're all fractional in values. There's 3 3/16, and this is 4 5/8. And what else do I need? This one needs to be 7 1/8. This one is 4.625, and this is 3 3/8. And this one is, I think, 7/8. Alright, does that look correct? I guess I missed that one. That one's 1.4, I think. Alright, so now what? I still got some blue on here. And if I move this thing around, it's correct to itself, but I just need to put this on the origin, so I need to tie that point to the origin, make those coincident. Alright, so now I've got a fully defined sketch, and the numbers seem reasonable to me. So I'll get out of the sketch. Alright, so now I'm ready to do my sheet metal command, and we don't have our tabs up here. There's a tab for sheet metal features, and we just need to add that to our list of commands up here. So if yours is not showing up like mine isn't, just right click on the tab, go to tabs, and turn on sheet metal right there. And you can see we've got lots of different tabs that aren't up there. This thing's got a lot of features that we haven't learned about yet, but we'll get to them eventually. So I'm going to turn on the sheet metal tab, and there it is right there. So when I do the first feature, I'm not going to do an extrude. I'm going to do a base flange tab. So I'm going to select this, pre-select the sketch, hit base flange tab, and this is where I want to tell it what the thickness of my sheet metal is, what the K factor is, and what the inside bend radius, because I want that to propagate through all the rest of the part. Because the sheet metal part is just one thickness, and so it doesn't make sense to keep telling it what the thickness of each flange is, because they're all going to be the same. So in my case, my part is 1/16 of an inch. The K factor for mine is 0.44. Yours is whatever I assigned to you, and we'll say OK. And so it makes it, looks like an extrude, but it's a sheet metal feature. And on the tree over here, I've got my base flange tab. There's my sketch. And we have to go into sheet metal. This is a feature that it made for us for free. The first feature is always a base flange tab. And so I need to come in here and edit this feature and see where my bend radius is. And there it is right there, right here. So the bend radius, the rule of thumb is different rules of thumb. I think for this project I was going to make it 1.5 times the thickness, and so sometimes it's 2 times the thickness, so whatever I'd assign for the project. So in this case I want to make it 1.5 times. So there's a default bend radius, there's a default thickness, and there's a default K factor. So now I just need to start what I call pulling flanges. And so this is where this sheet metal module really comes in handy. We're going to do a edge flange, and it's got lots of different options, but the one I want to show you is what I use as the default options. We're going to grab this back edge, and we're going to pull a flange. So I'll just pull it out here, and it's put the bend radius on there, it's pulled it out, and in this case I want this to be 3.75. And it's already got the default, see there's that default bend radius. It doesn't ask me to type it in again because it's going to be the same everywhere. And so there's the first flange, and now I'm going to pull another flange, edge flange, grab this far edge here like I did before, and pull a flange this way, and that one I believe is 1.8. And And then I pull one more flange over here on the other side. Edge flange. We'll pull a flange from the back edge. And we'll click somewhere out here and we'll change this to 0.75. And now I've got starting my part. So now you can go in and do a sketch on this face, draw some rectangular pockets, dimension those. I wouldn't put fillets in there. We can put these fillets in there as features like we've done on our other assignments. And then maybe make another sketch and do the 6 holes. And then make another sketch down here and do these 4 holes in a pocket in those 2 holes there. Notice on the drawing we've got some chamfers. And so when I use those, we can use these regular SolidWorks commands like we have in the past. I'll go chamfer, and I'll put my chamfer on these edges. There's a pair of chamfers there. And I want these 2 callouts to be in 2 different views. So I'll make that one chamfer there and make them 0.1 by 45. And then we can do the same thing over here. So even though this is a sheet metal part, you can still use those other familiar SolidWorks features to do tapped holes or through holes or cuts and extrudes and things. Alright, so I'll let you worry about getting those other features on there. So now let's see the magic of how to make this flat pattern. So you'll notice there's a feature at the very bottom it created for us automatically. And what we can do is we can right click on this feature and unsuppress it. It's by default it's suppressed because I don't want to do a flat pattern normally. I want to see it as the part is manufactured. But if I want to unsuppress that, you'll get your flat pattern. And it flattens it out and it does all those calculations to calculate the bend allowance, the bend deduction, all that stuff. And so now you can go in here and measure, evaluate, measure. And if you measure the distance from this top surface here down to this bottom edge here, that value in SolidWorks should exactly, whoops, it's on millimeters for some reason. Let's go to inches. These numbers should match your values exactly. There's the normal distance, 9.931, so that should be what I calculated with my hand calculations, and it also should match BendWorks. So all 3 of those match, you have high confidence that your model and your calculations are all correct. And then you do the same thing on the other side to verify it's done correctly. You go the distance from that face to this face, and that is LT2, and that should match your calculations as well. So we're going to go back in here and suppress this so it looks like that. Alright, so we'll have another video to talk about sizing those holes as part 3 video. So maybe I'll stop right here with this part 2 video, and this should get you to learn, this will at least show you how to use the new sheet metal commands, how to do ordinate dimensions, and again that'll be handy. I'll show you in the 3rd video when we do our drawing how to display those ordinate dimensions. So that's for now. We'll see you in the next video.